All right, this is a challenge and a real-world connection problem under our topic of factoring x squared plus bx plus c. I really encourage you to take a look at these problems, pause the video, try them on your own, and then check back in and see how you did. So the first one on the left is it's a pretty challenging factoring problem. Okay, x to the 8th minus 6x to the 5th minus 16x squared, and our task is to factor it completely. So we don't know what the end result might be. We just want it to be factored as much as possible. Okay, so I can see that there's a GCF that we can work with first, and then we can pull an x squared out front. Okay, so that's going to turn this into x squared, x to the 6th minus 6x cubed minus 16. And then let's see what I can do. It looks like I can factor this trinomial into the product of two binomials. So that's the thing that we've been doing with the FOIL method, the factoring a trinomial into two linear binomials. But here instead we'll have an x cubed to start off each binomial. And then we need to think of a couple numbers whose product is negative 16 and whose sum is negative 6. So it's going to be a minus 8 and a plus 2. So we could imagine foiling this stuff together and getting this x to the 6th minus 6x cubed minus 16. Okay, so we're doing okay so far. We made some progress. Let's see. So now it looks like we're going to use the difference of two cubes. And I have that formula inserted for you down here. It's not a formula or a rule that I have committed to memory, so that's why I pasted it in. I don't think you need to commit it to memory either, unless your teacher asks you to do it on a quiz or something. But we can apply that to this piece right here. And let me rewrite our statement. This is x cubed minus 2 cubed times x cubed plus 2. Okay, so I hope you can see how that is a difference of two cubes right now. So let's rewrite what we have. So we have an x squared, and then we're just going to follow the process down below. This is x minus 2 times x squared plus 2x plus 4. And that's going to then continue to be multiplied by the x cubed plus 2. And then we're going to take a look and see if there's any other work that we can do here. That's just x times x. We can't factor anymore. X minus 2 can't be factored. Take a look at this. Can that be factored? Are there numbers that multiply to 4 and add to 2? There aren't. Doesn't look like that can be factored. And then the sum of two cubes. There's a complicated algorithm here that we could use that's similar to what we just did. But this 2 right here isn't a perfect cube, so I'm not going to go ahead and do anything more with that. So it looks like we have a good final answer right here. That would be our final answer. All right, next one. Next one's a lot easier, okay? That's a little bit of a breath of fresh air here. So the area of a rectangle is x squared plus 5x minus 24, and its height is x minus 3. Determine the length of its base in terms of x. So let's draw a picture here. We have a rectangle, and I don't know what its scale, size, or shape is, but let's say it's something like that. And the whole area is x squared plus 5x minus 24, and its height is x minus 3, and we're wondering what its length is. We're just factoring. That's all we're doing, okay? So we have x minus 3 times something has to equal x squared plus 5 plus 5x minus 24. Okay? And this is actually an easier factoring problem than what you've done before because we have the x minus 3 already figured out. Okay? So we're going to have an x in here, and then a negative 3 times what gives us a negative 24. Well, it's going to be a positive 8. And do those two numbers add together to be a 5x? They do. They add together to be a 5. Okay? So this is going to be my my solution, x plus 8, is the length of this rectangle, because those two terms will FOIL together to get us the x squared plus 5x minus 24. All right, that's a good place to stop.